Okay, now I'm going to explain this one, type 2, how to find out the solution of a linear partial differential equation, again by Lagrange's method. Now, in type 1, what we did is that we can find two independent solutions by considering the first two fraction, or the first and the third fraction, or the second and the third fraction. But in this type 2, you will be able to get only one independent integral by using the procedure of type 1. But to get another independent integral, what we need to do is, with the help of that integral or the first solution you are getting, by using the procedure of type 1, then we'll be able to find out the second integral. Directly we'll not be able to consider the first, take the first two fraction or the last two fraction or the first and the third one in order to get another independent integral. So we have to apply that solution or the first integral in order to find out the second independent integral in this case. So let us solve this problem by which is of type 2. P minus 2 cubed is equal to 3x square sine of y plus 2x. So now what we see here is that you can express this one as p in 1 into p plus minus 2 into cube is equal to 3x square sine of y plus 2x, which is of the form pp plus cubed is equal to r, where capital P in this case will be 1, the coefficient of small p, and capital Q is equal to minus 2, and capital R will be this term on the right hand side. So the Lagrange's auxiliary equation in this case is given by dx by capital P is equal to dy by capital Q is equal to dz by capital R. So if you substitute the value of P, Q and R, then you'll get dx by 1 is equal to dy by minus 2 is equal to dz by 3x square sine of y plus 2x. So now let us use this first two fraction. By taking the first two fraction, you can get one independent integral. So this one, if you integrate this one, you'll get x is equal to y by minus 2 plus some constant c1, or 2x equal to minus y plus 2 times of c1. 2 is a constant, c1 is a constant, so you can replace it by another constant. So 2x transfer this y to this side and it become plus y. This is equal to, say, c. Name it as equation 1. So you have got one independent integral or one independent solution. Now what we notice is that I cannot take the first and the last fraction to get another independent integral, because here if I take the first and the last one, then the x variable and the z variable will be are the two variables that are involved. But we have the y variable also in this case. So therefore, I cannot use that the method that I have followed just now in order to get another independent integral. Similarly, if you take the second and the third one also, you see that the y and the z variable only must be involved. But here we have the x variable also. So therefore, with the help of this equation 1 now, we can find out what will be the second integral. So what you need to do now, to consider in this case this one and the first and the last. So it will be dx by 1 is equal to dz by 3x square sine of y plus 2x. So if you consider the first and the last one, then we notice that the y variable is present there. So what you need to do, replace this y plus 2x by c. So this can be written as dx is equal to dz by 3x square sine of c. Sine c. So now you see that 3x square can be cross multiplied to this side, and you get 3x square dx is equal to dz by sine c. Now integrate this one, you'll get 3x cubed by 3 equal to integral of dz will be z divided by sine c plus c2. Or 3 can be cancelled, you'll get x cubed is equal to z by sine c plus c2, or x cubed minus, or I can cross multiply the sine c to this side. Then what is c? You have to replace back that 1 by 2x plus y. So it will become x cubed into sine of 2x plus y is equal to z plus c2 into sine c. or C2. What is C2? We need to get a value of C2, so it will be x cubed sine of 2x plus y, then minus set whole thing divided by sine of 2x plus y. Or what I can do now is that it's okay, C2 is equal to this one. So what will be the solution now? The solution will be given by C1 is equal to phi of C2. So what is C1? It will be 2x plus y. This will be equal to phi of this one, x cubed sine of 2x plus y minus set whole thing divided by sine of 2x plus y. So this will be the general solution for for this particular problem. Now, let me solve one more problem so that it will be more clear with this one. Let us solve this case of p minus cubed is equal to set by x plus y. Here again, this one is on the form, you can express it as p plus minus 1 into cube is equal to set by x plus y. So what is the auxiliary equation or the Lagrange's auxiliary equation? It will be dx by capital P, which is a coefficient of small p. Here it is 1, is equal to dy by capital Q, which is a coefficient of Q. Here it is minus 1, is equal to d set by capital R, that is set by x plus y. So you consider this first two fraction, then dx by 1 is equal to dy by minus 1. Integrate this one. If you integrate it, then you'll get x is equal to minus y plus c1, or c1 is equal to x plus y. Name it as equation 1. So we have got one independent solution. Now let us consider by taking the first one and the third one, or the second and the third one in this case. So if I take the first one and the third one, then it will be dx by x is equal to d set by set upon x plus y. But you see here the x variable and the set variable only must be involved, but we have the y variable. So with the help of this equation 1, we can eliminate for the time being the y variable. That is, this whole term x plus y can be replaced by c1. So you can write it as dx is equal to d set by set upon c1, which can be easily integrated where there are only two variables involved in this case, only the x and the set variable. So we'll get it as dx is equal to c1 d set by set. Or if you integrate, then you'll get x is equal to c1, then integral of d set by set will be log set. So this implies that x by log set is equal to c1, or plus with some constant c2. It will be x minus c1 log set is equal to c2. Transfer this term to this side. Then what is the value of c1? The original value of c1 from equation 1 is x plus y. So now you can replace back by that one. You'll get x minus x plus y into log set is equal to c2. So name this as equation 2. So I've got one solution as c1 is equal to x plus y, and another one as c2 is equal to x minus of x plus y into log of set. Therefore, the general solution will be given by either c2 is equal to phi of c1, or c1 is equal to phi of c2. It will be the same thing because we have discussed it in the beginning. So in this case, if I express c2 as phi of c1, then you'll get it as x minus x plus y log set, because this is c2, is equal to phi of c1. c1 is x plus y. So this is the method of finding the solution of a partial differential equation by Lagrange's method for the case of type 2.